Hello everyone, today we are going to develop an artificial intelligence based question answering bot with the help of Hugging Face transformers. My name is Shazeb Hamid and welcome to AI Studio. A question answering bot is an autonomous system that gives answer to whatever questions you are asking it to. There are multiple types of question answering systems available like extractive question answers, community question answers, long form question answers, open QA and closed QA. In this particular video, we are going to be talking about extractive question answer system. Specifically, we will be talking about a review based QA system in which we are going to discuss the feedback of the customers related to a certain product, with the help of which we will be able to analyze what are the answers to specific questions. So let's go into the project. The first thing that we need is installing dependencies. Okay, so there are three main dependencies that we need to install here. The first one is we are going to be using a dataset from the library datasets, so we are going to install that. The second one is we are going to install transformers, which is a Hugging Face library that we are going to be using for development of our bot. And the last thing that we are going to install is pip install pandas. Okay, so there we go, write it and then run it. I have already run that, so these libraries are already installed inside my computer. After installing these libraries, the next step is to import pandas as PD, because we are going to be using pandas library in the project later on. Okay, so let's run it and let's move on. Okay, so after that, what we are going to discuss now is the dataset. The dataset that we are going to be using is subject QA dataset. Here we go. This is the dataset. It has multiple subsets including electronics, grocery, movies, restaurants, trip advisors and books. The subset that we are going to be using is books, and it has a split of test, train and validation inside each subset. Okay, so as you can see, this is the dataset. You can also go to dataset viewer, right, and there we go. This is the complete dataset, as you can see. Okay, so let's go back to our code. There we go. So this is the dataset, and to import that dataset from the library, what we are going to write here is from datasets import get underscore data set underscore config config underscore names. Okay, so let's run this, and now let's enter a few new cells also. Okay, so the next thing that we are going to do is, as I showed you, that it has multiple domains in it: books, electronics, grocery, movies, restaurants and TripAdvisor. So to see those domains here, what we will do is we will write domains is equal to this library, this module, and inside that what we are going to do is we are going to write subj question answering dataset, the same dataset that I showed you. Okay, so let's run it and let's print out the domains. There we go. We have these domains: books, electronics, grocery, movies, restaurants and TripAdvisors. Okay, so we are going to be using books from this, and the next step is to load the dataset from data sets import load underscore dataset. Okay, and then what we are going to do is we are going to write subject QA is equal to load underscore dataset, and under that we are going to write subject QA, and the name of the subset that we are going to use is books. Okay, so you will write whichever subset you want to use here, and this is the way to load the dataset from the dataset library. Okay, so it will take a little time to download it, and after it is downloaded, what we can do is we can check if our data set is okay or if it is working fine. Okay, so let's suppose I want to show you some answer of the data set. Then I'll write subject QA, and if we run it, there we go, subject QA, sorry. Okay, if we run it, we have this dataset dictionary, then we have train, test and validation, 3 set of datasets available. Okay, so let's suppose we want to see the train part. Okay, so then we will write here train, TRAIN. Okay, so it will show us only the train features. So domain, NN mode and all of these features are available in training. Okay, so as you can see here, there is a column called answers. So let's suppose we want to get into the answers. So we will use another square bracket, and this time we will write answers. Okay, so that will make us enter into this column. So let's run it. These all the answers that are available in the subject QA train dataset. Okay, let's suppose we want to see the first one, then we will write 1 here, and it will show us only one answer. So for the first answer, the text is the subject matter would be interesting, and then there is the answer is starting at 262 token number, and then the subject level and subject score, everything is available here. Okay, so if we want to, let's suppose, see the question, so we will copy it from here and then we will paste it here and run it, and these are all the questions. Let's suppose we want to see the first question. Okay, so this is the first question, and this was its answer. Okay, wait a minute, it is answers, right? So this is its answer. Let's copy it, cell, let's enter it into another cell and write question here. So how is the detail is the question, and the subject matter would be interesting is the answer. So we can check for different questions, right? If we write to how is the matter, and then this will be the answer. The answer is not available for this one, but we can check it for multiple question answering combinations. Okay, so the next thing that we want to do is we want to split the answers and make data frames out of the answers. Hugging Face saves the answers to each question as a nested dictionary. So what we want to do next is we want to split the dictionary into suitable answers. Okay, and we also want to divide it into train, test, split. Okay, so to do that, the first thing that we want to do is we want to enter a data frame. It will be more than one. Let's write DFS. Okay, so the next thing is we want to split it into the okay, so what does it say? It says that we want to use the split variable in the dataset, and from the subject QA dataset we are going to flatten the whole dataset and get the D set and split out of it. And what should be the result of it? The result should be this: DFS is equal to DFS for split is equal to dataset dset 2 underscore pandas. Okay, so what it will do is it will convert the whole dataset, which will be one at a time from the subject QA complete dataset. So one will be taken and it will be converted to through pandas to a data frame, and it will be saved to that data frame. So after that the next split will come and that dataset will be taken out from the subject QA dataset and it will be saved to the next split of the data frame. So that's how it will work, and the split will be train or test or validate. These will be the three types of variables that will be used in split. So the data frame at the end will be splitted into multiple data frames of training, test and validation. Okay, so I got an error here. Let's see what is wrong. Maybe I did not use this. For split dataset in subject QA dot flatten dot items, right? I did not write dot here, dot items. Okay, so this is it. Now we have splitted the data frame into train, test, validation and also flatten out to get our specific results. Okay, so the next thing what we can do is we can see what kind of splitting we have done. So we will use the same loop, but with the difference that this time it will be in the DFS data frames. Data frame in DFS dot items. So what we are going to do is we are going to print the number of questions in test, train and validation. Let's suppose number of questions in for test, train and validation. What we are going to write here is split and then data frame, and in that dictionary part we are going to say we are going to shift it to the data frame, and in the data frame what we have is the ID and the unique variable, unique, like this. Okay, so this is the command, and we are going to write F here, and after F this there we go. So this will be the whole command in which we will see what are the result of the train test and validation split. Okay, so we got an error again. Let's see into it. Okay, so I did not enter the commas for the ID. Okay, so I have seen the error. The error is in this cell. We did not, it is for a function, not a variable. So we have to use the round brackets here. Okay, so we will run this one and then we'll come back to run this one. There we go. So the number of questions in train dataset is 1314 and the number of questions in test dataset is 345 and the number of questions in validation dataset are 256. The next thing what we can do is we can see what type of questions are mostly available, and we can also see what are the main columns that are used in the questions. Okay, so first we need to write the columns of the QA dataset that we need. We need the title, question, we need answer.text, right, the text part from the answer, which is, we also need the answer stored part, which is also stored in the answer column as I showed you before, answer underscore start, and at last what we need is the context. Okay, so the need of the context is we are going to use the context to make our question a little bit better. Okay, so these are the columns that we are going to use. Okay, so from these columns what we can do is we can take a sample data frame. This sample data frame will be random in nature. Okay, so it will be from, of course, the data frames that are available to us, and it will be from the train dataset for sure, and we can take the QA underscore columns here dot sample, right, and in the sample we can take any random value. Let's suppose we say something like this one, 2 random state is equal to 7. Okay, so let's run this. Okay, so we have again an error that says that it is not available in the index. Okay, so in our data set we had the label answers, as you can see here, but here I wrote answer.text. so let me change this and let's run it again. Okay, so now we have a sample df in which we are going to use all of these columns and randomly take any of the data frame as a sample data frame. Okay, so let's see which data frame has it taken. This is the random data frame that it has taken. It has the question why none is likable, and the answer is this one, answer.text, and it is starting at 119 and it is ending at 156. But as you can see from right here that the answer.text and answer start of this second question does not have anything. So this is something that we will have to see in the future, that what we need to do about these empty values. Okay, so before that, the next part is to see what are the types of the questions that are available. Okay, so to do this, the first thing that we need to have are the start IDs and the end IDs. We are going to take them from the sample underscore df file, right? Okay, so answers. Okay, so the context is present between the start ID and the end ID, but before that we need to get the start and end IDs. Okay, so sample df answers dot answer answer start underscore start. We can see it from here. We have written this one, and we also need to see its location in the sample data frame. So locate it in the matrix. Okay, so the next thing is, what is the ending ID? So again it will be sample df, and the end will be wherever the text answers ends, whatever is the length of the text. After that the end ID will be available. Okay, so we need to write here answers dot text. Okay, so it will start from answer start from here, and it will have the length that this answer has, and it will end at wherever the place this answer text ends. Just like this. Okay, so at the end what we are going to do is, we are going to say that sample underscore df context dot location, to see what is the location of the context, right? And it will be from the start ID to the end underscore idx. Let's run it. Okay, so it is giving another error. It is saying that the sample df is not right. Okay, so let me check it. Okay, so there is something that I missed. The end ID will have the length of everything that was available in the answer.text, and with that we are going to add the start IDs. So the end ID will be equal to start ID, whatever the value is here, plus the length of the sample data frame that has the answer.text. Okay, so let's run it again. So there we go, we have the answer here. From the sample data frame, the context that we get is the character were not likable and it often felt forced, a little bit pretentious, just like this one. Okay, so what is the next step? The next step is to see what type of questions are available in our data set, so we can make a better sense of what is the availability here. Okay, so what are the main type of questions that are normally used? We are just going to write a few of them, like question types is equal to, let's make an array of questions like what. Another that is used is how. Another that is used is of course, and does, right, and then do with a small o, of course, and then was, and then where, something like that, and at last why. Okay, so these are the questions that we are going to see in this tutorial. You can enter your own questions if you want. Okay, so if we want to see how many questions are there in each data set, let's suppose we want to see how many questions are there in the training data set, in the training split. So for that, what we will do is, for q we will write a simple for loop like this, and the count variable dictionary basically should be changed according to this q, and it should be equal to data frames and train, and then what are the questions, and then we are going to take the strings that start with the question types that are available here. So the questions that start with what are going to be separated from the questions that start with how, and they are going to be separated from the questions that start with is. Okay, so for that we are going to use built-in command starts with q. Q is the question that will be what in one case, how in the second case, and so on and so forth. Dot value underscore counts. So we are also going to use this function value counts that is going to give us how many values are there for each question. So first one will be what, and it will be calculated how many of these training data set questions are starting with what, and then the same will happen with how, then the same will happen with is. Okay, so let's run it. So it is saying that the name count is not defined. Let's see what is written here. It is written counts, and here we are writing count. Okay, so let's change it to counts. There we go. Let's write counts again. Yes, now it is showing that what is repeated 265 times, how is repeated 712 times, and this is the whole dictionary of the question starting words. Okay, so now that we have this one, we can also see for the best words that are here. Okay, so as you can see how it performs very good, other than how, what performs very good, and is performs very good. Okay, so what if we want to see some sample questions for these three words? Okay, so for that we are going to write for question underscore type in, which one are we talking about? How, right? It had a good response, and then what, it had a good response, and then is, it had a good response. So these are the three question types that we are looking for, and what we want from it is we want to print out the questions that have these three words. So for that, what we are going to do is we are going to check in the complete data frame which are available or not. Okay, so it is a whole command. Okay, so we are going to need only those values that have these three starting points, those sentences. To get that, we need to first enter into data frame train, and then after entering into this data frame train, what we are going to do is the next part, like this, the next part was question here. So what will we write instead of question here? Okay, so we need that question. Okay, so the question that we need must start from how, what and is. Okay, so to get to that question, what we are going to do is we are going to use this same function and this same command with only a slight change. Okay, so like this, and here we are going to write question underscore type. So let's first see what this means. What this means is we will have the question that starts with those three values from this, but there is something that we need to change from this one. We are not going to write, of course, question here. We are going to write simple question, which is in this loop. Okay, so every question in this data frame that starts with these values will be taken out. Every question in this data frame that starts with these question types will be taken out. Okay, so what we after this what we need to do is we need to have a random sample of these questions. So we have done sampling before. Let's just write 3 and random state is equal to 42. Random underscore state is equal to 42. Okay, so after this there is only one thing that is left. We have to write the question at the end because we need the question from it. This command is a little handful. If you need any more help in this, you can ask me. Okay, so let's run this. Okay, so the next thing that we need to do is we need to write print question here, and let's see what are the sample questions that it is taking. There we go. So the first question is how is the choice, the second question is how is the child, and these are all the questions that it has taken. From each sample it has taken 3 different questions. So 3 for this one, 3 for what, and 3 for is. Okay, so that's how we are going to get the questions out of it and to see what are the types of random questions that are available. Okay, so in the next step what we are going to do is we are now going to shift towards Hugging Face, and the first step is to import the Tokenizer from Transformers library. Transformers import auto tokenizer. Okay, so we have imported the tokenizer, and the next step is to check the model and get it out of the Hugging Face. Okay, so the model that we are going to go is the mini LM cased squad 2. It is already fine tuned on a data set of subject QA. Okay, so first to write the model checkpoint, we will write once model checkpoint and then we will keep on using it again and again. Model checkpoint is equal to, so the name of the model that we are going to use is deepset slash MINILM mini LM and then uncased and then squad 2. Okay, so we are going to use this model. Okay, so let's check if this model is available or not. There we go. We are going to now enter this into our tokenizer. Sorry, tokenizer is equal to, the command is auto tokenizer dot. Okay, so if you are familiar with Hugging Face before, you know what all of this means, but if someone is not, then it is just going to take this model and the checkpoints in it, and it is going to enter it from the pre-trained models. So model underscore checkpoint. Let's see if this model is available. Okay, so it is, the word is not right. We have written auto tokenizer. Okay, so we will have to wait a little bit for this to be loaded. So it is loaded now. Now we can ask it a question, but before that we are going to give it a context as well as a question. Like a question can be of different type. For example, okay, so now we are going to enter a question and its context here. Okay, so do that. For doing that, we are going to open the subject QA dataset from here, and as we can see, we are already in the subset books and we are already in the train split. So we are going to get a question and its context from here. Let's take this as a question. How is the detail? Okay, so this is our question and we are going to write it here. And the second thing is the context, right? So the context is, we are going to write the context here because it is a paragraph. I used this one. Okay, so this is the context, the complete context of the question, right? Okay, so the next thing is we are going to enter the inputs into it, into the token through the tokenizer. We are going to enter the question, and with that we are going to enter the context as well as we are going to enter return tensors because we are using PyTorch. We are going to write this like this. Okay, so let's run this. There we go. This is the question, this is its context, and we have now put this into the tokenizer. So the next step is to see how it is decoded. To see that, we will write print tokenizer.decode for the input IDs. Tokenizer.decode for the inputs, right? And we are entering the input IDs in here, and then we are going to enter 0 here. Oh, sorry. Okay, so now let's run this. So this is it. We have the complete interface here, in which how is the detail, and while I would, this is the complete the context that we had in that. Okay, so after this what we are going to do is we are going to start the modeling, and before that we have to obviously install the auto model for question answering from the Hugging Face. Before that, let's get torch as well as from transformers import auto model for, oh sorry, there is no space here, for question answering. Okay, so what it does is it has the complete auto model for question answering available. So we are going to download it. Okay, so it is giving us an error. Maybe this F is capital. Okay, so let's try this one. Okay, so now we have this the auto model for question answering from the GitHub. Okay, so after that we are going to get the model for the checkpoints that we already have. So we are going to write model here, and then we are going to copy this because it makes a little bit mistakes. Okay, so now after that we are going to write from pre-trained, and then we are going to write model checkpoint. Okay, so now we have this model already in our system in the variable model. Okay, so now we can just see its output if we want. This one is not necessary. So if you want to do that, then just write this. Because outputs is equal to model with inputs. After this, I am going to print the outputs like this. Okay, so there we go. You can see that it has printed out the sequence of the outputs and their scores. Okay, so to get the answer from this model, there are two ways. The number one way is to use Hugging Face pipeline, and the second way is the conventional way. Okay, so first we are going to use the conventional way, and after that we are going to use the Hugging Face pipeline, through which the code only limits to 2 lines. To get it through the conventional way, what I need to do first is I need to decide about the logits that we have gotten from these outputs. So these are the starting logits, and these are the ending logits. Okay, so I think the name is outputs. Let's run this again. Okay, so we now have the start and end logits here, and after that we are going to show the space and the size of the logits, mainly the shape. Okay, for that the first thing is we need to print input ID's shape, and here we need to do inputs dot input underscore IDs dot size, and we are going to do it like this. Okay, so it will print the input ID size right here to see if the sizes are same. Okay, so the input ID size is 1 to 86. Now let's do the same thing for the start logits and the end logits. Okay, to see the start logit size, we are going to write here start underscore logits. So as you can see, it has the same size, and at last we are going to see and underscore logits size. Okay, so as you can see, it has the same size also. Okay, so now we can keep on working on this because the size is same for the input as well as the logits. Okay, so now we need to have a start ID and an end ID, just like we had for the sample ID. So for that we are going to write it as start IDs and get it from the start logit function. Before that we need to use the argument maximum function, which will get the maximum value out of it, and we will write start underscore logits. Okay, and in the same way we are going to write the end underscore IDs is equal to torch dot arg max end underscore logits plus 1, because its index starts from 1 plus. Okay, so we are going to write it here, and then the answer span, as we have discussed before, is from the start ID and the end ID. Okay, so to see that we need to write answer underscore span is equal to inputs. We are going to use the inputs command here, and then we are going to write here input underscore IDs, right, and then we are going to write 0 here, and then we are going to say that start with start underscore IDs and end with end underscore IDs. Okay, so something like this. Okay, so after calculating the answer span, the next step is to get the answer from the tokenizer. ANSWER answer is equal to tokenizer, right? So tokenizer dot decode, and what are we going to decode? We are going to decode answer underscore span. Okay, so the next step now is to print the question and the answer. So first we are going to print the question, right here. It is a dictionary, so we are going to use curly brackets like this. Okay, so the question is how is the detail, and now we are going to print the answer. Okay, so the simple mechanism that we are using does not work on a very long passage. That's something we will cover in the future. So that's why we have to change the question a little bit. Let's see if we get another question. Okay, so how would you describe the story is the next question that we are going for, and this is the answer that we are going for. Okay, so this context, this was a little bit longer, more longer than the one that our code can handle up to this point. We will cover the bigger passages in the future. Okay, so I changed the question and the context here in the code above, and let's run the code again. So let's do it, let's do the whole complete thing again. Okay, let's wait for it. Okay, so let's go until the end. How would you describe the story is the question, and the answer is the book is so much better. Okay, so you can see that whatever question you ask, you can get an answer to it. Okay, so we can do the same thing for something called with the help of something called a pipeline. So with the help of the pipeline, the model gives us answers in a very speedily way. So to do that, what we need to do is we need to import from transformers, import pipeline. That is the first command that we are going to use. And the second command is, let's see if it is running. Okay, and the second command is pipe is equal to, so we are going to develop a question answering pipeline here. Pipe is equal to pipeline, and here we are going to tell it which type of pipeline it is. So we are developing a question answering app, so for that we need question answering. Okay, and after this we are going to use the model that was already available, and we are going to use the tokenizer that is already available. Okay, so we have taken that into account, and after this what we are going to do is we are going to use this pipeline for our question, right, the question that we had, and with the context that we had, and we are going to take the first 3 answers. Okay, so let's run this. It is giving an error. It is saying that H argument, so something is fishy here. Okay, so we will have to write question is equal to question, context is equal to context, and top k is equal to 3. So these are the 3 things that are needed to run this pipeline. Okay, so this is the answer that we are getting. So right here we are also getting the score with it, like 0.15 is the score for this answer. So that's why this is the perfect answer. The book is so much better, and 0.07 is the score for this answer. Okay, so that's how we can generate this with the help of pipeline. So these are our answers. I hope that you like the video. You can subscribe for more projects like this. We normally develop projects related to machine learning and data sciences. So don't forget to subscribe the channel. Thank you very much.